session. So, welcome again, everyone. My name is Jakob Ehn, and I'll be talking about serverless microservices with Azure Container Apps. So, I work at a company here in Stockholm called Active Solution, where we're developing a lot of Azure solutions, a lot of containers, a lot of Kubernetes. So for us and for me, this new service from Microsoft in Azure is actually really exciting because it promises to make a lot of things simpler and more approachable. And I'll talk a little bit about that. So this is me. You can follow me on my blog and on Twitter. I've written some books that nobody reads anymore, but actually dealt a lot with the things that that Björn was just talking about. So I've been in that product since 2004 in the early days when it didn't run in the cloud. It was running on premise on servers. It was good times. So anyway, microservices and containers. Why is this such a good fit? We have to start there, right? So the promise of microservices is that you split your solution up in many smaller services. Each service should be able to pretty much select the technology, the runtime, the date type of database, and so on that fits for that particular service, and that is great. Can typically make a lot of teams more agile, more faster to develop things. At the same time, it makes it a little bit more problematic when you now need to deploy like 40 different types of runtimes and stacks and different types of databases and so on. So that's why it makes so much sense to package your microservices into containers, because now you just have a container to deploy. So you can build it the same way, you can deploy it the same way, you can host it the same way. It doesn't really matter what's inside that. So for the operations part, it makes it so much simpler if you wrap this in containers. So I won't talk a lot about microservices. That's kind of a topic on its own. So more around running multi-container apps. So if you're running building a system that contains of more than one system, so not just one web app, but you typically could have multiple APIs. You could have background jobs, things that process things in the background and so on. What do you typically need for a service where you will host these multi-container apps? Well, first up, you will need to be able to do service discovery. If you have multiple containers, multiple services, you need to be able to know where are my other services running. How do I call them, right? That's pretty basic. You also want to be able to deploy new versions without causing any downtime. So very important, particularly when you have many running services. You can't keep track of everything. You can't pull the whole system down every time. You want to be able to deploy a new version of either of those services without causing any downtime. Scaling is, of course, also important. That is also one of the reasons why you want to move to microservices, to be able to scale these smaller parts independently of each other. You don't have to scale the whole thing up and down. So you want to be able to auto-scale your services, both on things like metrics, like CPU memory, but also on events, because many of our systems nowadays are event-based. So you want to be able to scale, for example, on the number of messages on a message queue, for example. Monitoring, distributed tracing, these are things that actually becomes a bit harder when you do microservices, because now you don't have just one system, one log to look at. You have potentially 20, 25, 50 different services that all write their own logs, their own metrics. So you need something that actually can put the things together and aggregate it, and makes it easy for you to troubleshoot your services, to make sure they're healthy and so on. And also in kind of this day and age, you don't really want to care about your infrastructure. You just want to, run this somewhere in the cloud. You don't want to provision machines, beforehand. You don't really want to know about that. You want to just deploy a solution and only really pay for what you use. That is really the promise of the cloud, really. And in many cases, this is not really the case. And if we're looking at the options for running containers in Azure, there are a few options. The simplest one is probably Azure Container Instances, has been around for a long time. This is serverless containers really in Azure. You just say, run this container. I don't care where you run it, and I just want to pay for the amount of resources that I use. So you pay for the amount of time, the amount of memory, and so on. So that's great, but it's really meant for just typically short-running single applications, do like tasks or some kind of job or something like that. It's not really meant for like building a whole distributed system. You have Azure App Services, so when you are building web applications, you can run them as containers, and that works great for web apps. It doesn't work so well for other types of applications. You can kind of mickle around with it, but it's not really a great fit. It's a great fit for the web apps, but not so much for the other parts. And then you have the big beasts, Kubernetes. How many here are working with Kubernetes? A few of you. So Azure has their own managed Kubernetes service, of course. And so this is a great platform for running microservices, running multi-container applications. But then there's this new one. So this is still in preview, which I noted one effect of when I sat there half an hour ago and realized that it didn't work anymore, the demo. So sometimes things kind of stop working because it's in preview. But then I actually ran my Azure pipeline, redeployed the whole thing, and now it works again. So that's nice. But this is in preview. I think they're getting closer and closer to GA, so they're adding more and more features. So this is called Azure Container Apps. Kind of the, what do you call it? The key headliner or a thing is serverless containers for microservices. So the focus here is to make it a lot simpler. So this is actually built on top of Kubernetes. So when you run this, it's actually somewhere in the cloud. It will spin up a cluster for you and kind of create a little space for your applications, but you don't need to know about that. So you should just be able to focus on your applications, not the infrastructure. And we heard that so many times. I think they're getting closer and closer with this type of service. It doesn't really care what language or framework you're using, and of course that's because you're using containers, right? So it's built on top of Kubernetes. You don't need to know the concepts, but if you do want to actually move on to Kubernetes later on, you can do that because it's still kind of a good fit for it. And it's built on open source, which means that the product itself is not open source, but they're leveraging a lot of open source solutions. And I will talk about some of these things like Keda and Dapr, that is open source frameworks for making it easier to build microservices and also to scale microservices. And this is kind of built-in support for it in Azure Container Apps. So just some examples. Sorry for the quality. I just took this image from documentation, just explaining the different types of scenarios where you can do things like building public API endpoints, where you can do like traffic routing, and I will talk more about that. Background processing, jobs that run in the background, maybe do some transformations. Event-driven processing, typically some kind of queue reader, some application that actually reads things that comes into a queue. And typically you want to scale the number of messages increase. And also doing this like this microservice applications that actually communicates with each other. So deploying a container app is super simple. It's very, if you have used container instances, it's kind of the same thing. It's very similar. You first up create an environment, and I'll come back to what an environment actually is. But this is actually your place in the cloud where you can deploy your containers. So you start up with creating an environment, and then you can create your container application, which is basically then a reference to the container image that you want to use, a specific version. And you can configure some things like, how do I want to access this image? Does it need like public HTTP? Which port does it listen to, and so on. So this is a CLI. You can also use ARM or Bicep to do the same thing. So multiple ways of deploying it. And just for a break, I'll show you how to actually create one of these things. And let's first up head over to the portal. So if you just search for container app, you will see your container apps and your container app environments. So I already created 2 environments. So the first one, container app, also already has a running application in it, and I will show that later. The other one is empty, so it doesn't contain any apps. So there's no apps inside this environment.
Morning. Hey.
Uh-oh.
Sorry to interrupt.
Oh.
Have coffee, drinks, everyone feels ready?
Okay, thank you.
If not, it's still a good time to grab something. Otherwise, welcome sustainability breakout. Happy to see many faces here, and happy to see that you're interested in.
Can we fix this?
Has been someone forced to go here, or all here voluntary?
It's fine because I actually know this voice.
I was just wondering
from one of the other events, I guess.
Talking in the afternoon, I thought way to promote the afternoon session, and also I don't want to steal of your valuable discussion time. So I thought, yep, I just say good morning and just give a brief. Maybe later I share some additional stuff.
I get another one? Yeah. Okay.
And now I've added you. So the sound of the stream will come from your computer.
Okay, so this is just for the room then?
Yeah, just leave the headset off.
Oh, okay. Turn it off, I guess.
This one?
Yeah.
Should be off?
Yeah, well.
So why do I need it?
You don't need it anymore.
Okay. All right. So, okay, so can you hear me back there?
You know, how can we all work together and how can technology...
How can we all work together?
Too much time, but from my perspective, just like the observations I'm currently doing, which is from a personal perspective, sees the pressure, but I want to corporate pressure. And it's crazy times right now because, as you all know, it really gears up the pressure from the financial markets, from ESG all the way to recruiting. So that become like a fact that these days in interviews, you know, as corporates, you're.
Men nu borde du lätt att stänga av högtalaren bara. Om inte kör mick längre.
Just like a few years ago. The capital.
Upstairs, we can hear everything from downstairs.
And you can tell by my funny accent. But to give you like one perspective, Commerzbank, which is a huge bank, on day 4, there are 65,000 B2B customers to really have a climate strategy. And they literally say, like, look, if you don't have a climate strategy, we don't want you as customers. That's a reality. So on that note, a bunch of
Undrar om våra röster hörs. Ja, någon annan hörs. Bara vi som.
Precis, jag keynote. I want to have a breakout session.
From my perspective, it becomes more and more of a because I over and over, like here, when talking to people, actually, can be. Think about selling often the use so much unicorn opportunity. Major problem. No, we have anyone about I understand, but if you read the IP, this is basically the science. And, there is no like
Va? This is a web container, so it listens to port 80. So let's run it and see what happens. And it says now it's in preview, as I mentioned before. So there's no SLA and so on as of yet. So typically this operation is pretty fast. Of course, it depends a bit on the size of your container image, how long time it takes for it to actually kind of pull it to the target environment. And at the end, I'll also query the ingress. So now it says container app is created. You can access your app, and then it points me to this long URL, which is what you get by default. So let's click this one. And it says, welcome to Azure Container Apps. So very exciting application, of course. But you can see how easy that was to just create it, and it was actually pretty fast, and it's up and running. That's all I need to do. From now point on, I pay for the amount of resources. Oops, I'm not going to show that screen. The amount of resources, how long is that container running? If I pull it down, I don't pay anything again. So this is kind of the serverless parts. You just deploy it, and you only pay for what you're using here. And let's just take a look inside here. So now we can see we have the container app demo here. So let's just peek inside here to see what we can kind of do and watch here. And so I have the URL here. I have the reference to the environment. There's also this connection to log analytics, and this is where all the metrics and logs will go. And I will talk about that a little later. So let's go back to the presentation. So that was just a quick thing to show you to actually how to deploy a simple app. So let's talk about the concept then. So I mentioned this environment thing. So this is in real life, this is actually, if you know Kubernetes, this is basically a namespace inside a Kubernetes cluster somewhere. But you just, you can just create an environment. Inside that environment, this is where your container apps will run. And inside your application, you have basically one or more containers which will run inside a pod. So a pod is actually also a Kubernetes concept. Typically, this will just be one container. So let's say this could be the web container that I just deployed. So in some cases, you can run multiple containers inside the same pod, but the most common thing is actually to just run one container there. But there's one more concept here, and that's the revision. And this has to do with how you deploy your application. So every time you deploy a new version of your container, it actually creates what's called a revision. And let's say I have this container running. Let's say it's the one that I just deployed now. If I would deploy a new version of that container, it will actually create a new revision for it. And this is how it deals with things like, for example, no downtime during deployment. So it won't tear down my old container. It will actually create a new one, a new revision. And once that is up and running and it shifts traffic to it, then it will delete the old one. So this is how you get zero downtime. This is how Kubernetes works under the hood. If Kubernetes, this is how it works. But this is not something you need to configure yourself. It just happens automatically. You can deploy new versions and you won't get any downtime. And that is actually really, really nice. And then, of course, you can have more containers typically. If you're building a microservice, you typically have more containers here. And these will now be able to talk to each other because they are now running in the same virtual network. So this could be a pre-configured network that you already have, or you can just spin up a network together with the environment. And in addition, then in the environment, you also have a log analytics workspace. This is part of the Azure Monitor. So if you're using Azure and monitoring, you know what Azure Monitor is. So basically, everything that your container outputs in terms of logs and metrics will automatically go into this workspace. And then you can do queries and visualizations and alerts based on that and based on all containers. So this is how you do log aggregation, for example. So just to kind of explain the concept of a revision a little bit more. So when you deploy it the first time, you get one new revision, which is then active. This is where all traffic is being sent. When you do an update that I just talked about, it will actually create a new revision. The old revision is still running. And once that new revision is up and running, traffic will automatically be shifted to the new one, and the old one will be put to inactive, and eventually it will go away. So again, this is how you achieve zero downtime, but you can also do more things than just that, because this allows you to do like traffic splitting. You can actually have multiple containers running, multiple revisions running at the same time. So for example, you can do things like canary deployments, which you might have heard of, which is basically a way for you to incrementally roll out a new version. So let's say you deploy a new version, but you don't want everybody to use it immediately. Maybe you want to send, for example, 20% of the traffic to the new one, because that allows you to kind of test it. And if it breaks, it doesn't affect everyone. So you can kind of deploy a new version and you can gradually route more and more traffic to it. You can also do things like A/B testing, running multiple versions of the same time for a longer period of time to compare to different, for example, to different implementations of a search algorithm or a login page or whatever. So you get a lot of cool things, and this is how you can actually configure traffic splitting. So you basically can say that I want to send 50% of the traffic to this revision, 30% to that revision, and 20% to the latest one. So you can typically build a pipeline that do this for you then, that incrementally rolls out a new version into your production. So cool things. Actually, I think I will skip this demo because I'm losing a bit of time here. And we'll mention this later anyway. So what about scaling then? Because it's easy enough to just deploy things, but one of the big things that you want to be able to scale it, your individual microservices. And this is where one of those open source projects come into play, which is called Keda. So when you deploy an Azure Container Apps environment, you automatically get this Keda component, and this allows you to horizontally scale your services through what's called a scaling rule. And this can be based on many different types of triggers. So it could be based on the number of HTTP requests coming in. So that could be quite a common thing. If you get a lot of requests to your API, then you can scale out based on those number of requests. But it can also be event-driven, as I mentioned before. So if you get messages on a queue or through an event hub, or it could be like the number of items in the Redis cache or something like that. Because then it doesn't really make sense to scale based on CPU or something. You want to be able to scale on something else if you're processing those messages. But you can also scale on CPU and memory. And again, it uses Keda under the hood. And so again, Keda stands for Kubernetes Event-Driven Autoscaling. So this has been around for a while and is commonly used in Kubernetes. But now for this service, it gets deployed automatically. You don't need to think about it. It's there, and you can just kind of use it. So they're basically building an abstraction on top of it. And so the nice thing, that's the URL if you want to read more about it. And this is kind of a picture that shows you how it works, but you don't need to care about that. So I just wanted to include this one because it just lists a lot of these different type of scalars, which means that you can. And this list is actually longer, but this is typically what you can scale on in terms of event-driven scaling. And I will show you how you can use this for scaling based on an Azure Service Bus. The other open source framework that kind of is super easy to use with container apps is called Dapr. Has anyone heard of Dapr? Just a few of you. So again, this is an open source project. It was initiated by Microsoft, but the development is completely in the open. It stands for Distributed Application Runtime, and it's basically a framework or kind of system to make it easier to develop and host microservices. So it consists of various building blocks that implements things that you typically want to implement in a microservice world. So for example, service-to-service invocation, make it super easy for you to locate other services. Publish and subscribe, this type of communication mechanism. Distributed tracing, secrets, also state management. These are things like if you're developing 20 or 30 microservices, you have to kind of do this thing over and over again. You need to select the state store to store your data. You need to call other services, potentially through publish subscribe patterns. You need to think about secrets. You need to think about distributed tracing, and so on. And so the idea is to kind of define these building blocks that you can use. And I want to say this is optional. You don't have to use this for if you do container apps. It's just they kind of make it easy for you to use it if you want to. And it kind of makes sense in many cases, I think, when you're developing a lot of microservices. But it's completely optional. And just to show you the kind of basic idea of Dapr is that it uses this sidecar architecture, which means that you have two services and they want to talk to each other. So, but instead of talking directly to that service, you will talk through this little sidecar object that runs next to your application. So every time you run, you get a little service next, which is called a sidecar. So you call that one, and then it's up to Dapr to actually locate the other services. So you just call that service that is called service B, and Dapr will figure out for you. And what's nice now is that you can run this locally. I will show that later. And I can deploy exactly the same code to Kubernetes or to Azure Container Apps, and I don't have to change anything. The service invocation will still work. So everything will look exactly the same, even if I run it locally or in the cloud somewhere. So in addition to just getting service discovery, you get a lot of extra things that Dapr do for you. So it will do secure communication. It will add things like tracing, logs, and metrics, because everything runs through this sidecar. So this is also how you get a lot of nice distributed tracing and metrics. And in addition, then through various types of metadata files, you can use these types of the building blocks that I talked about. So for example, if you want to do state store, if you want to store data in like Cosmos DB or Redis or Cassandra, there's like ready-made building blocks for it. Same thing for publish subscribe. If you want to, there's like different options how you would do that. So these are building blocks that actually implement that for you. So again, these building blocks, they typically cover like 95% of the things that you typically want to use. In some cases, you want to, you have to be more advanced, and then you don't have to use it. But in many cases, when you're writing small services, it's not that you typically don't have that many requirements of the needs you need to implement. So you need a simple state store. You need to be able to do publish, subscribe, or communicate. So Dapr goes a long way to just make it simpler. So I recommend you to look into it if you're building distributed applications. So if you do this with Azure Container Apps, they will spin up this Dapr sidecar for you. You don't need to think about that. It will always be there. And you can just use Dapr to call other services, and it will do this invocation for you. So that's pretty nice. So I'm going to show you a demo of this. So it's a super simple application. It's available online somewhere. I have a link at the end. It's basically consists of 3 parts. There's a web application, which will then call an API. The API will use PubSub to kind of publish an order, and then we have an order processing background thing here, which will consume those messages. So in this case, I will use Azure Service Bus for that PubSub communication. But with Dapr, then I can really just kind of plug it into to use something else. So for example, locally, I could actually use Redis just to have a local Redis instance. But when I'm in the cloud, I can use Service Bus. It stores its state in Cosmos DB. And then I will try to show you how to also be able to scale this. If I add some load to it, send a lot of orders to the API, then I want the order processing background worker to scale, to scale out, to be able to process the messages at a faster rate. So it will scale out. So let's take a look at this other demo then. So this is the application I talked about, where I have, let's zoom in a little bit more. Or basically, I have the 3 parts. I have the order web, the order API, and the order processor. And I won't go to. There's a lot of details in like how you actually run a Dapr application. And let me just show you one example. So I'm using VS Code here, and so you get an extension to VS Code for Dapr that helps you with a few things. But basically, when you run your application, you also want to spin up that sidecar I talked about. And this is what the VS Code Dapr tasks will do for you. So in addition to just run my order web and my order API, it will also spin up the sidecar. And I just need to configure to listen to various ports and so on. So kind of to show you what the code looks like. So let's take a look inside the order web, just to show you this sample of using Dapr. So the web, when I create an order, it needs to call the API I talked about. So if you look at the code here, let's zoom in a bit. I just I created this Dapr client. So I'm using the C# SDK, and I'm saying invoke method async on that one. And the only thing I need to specify here really is here is the name of the service, order API, and the name of the method, which in this case is order. So it will do now a post to that order endpoint on my order API. And I don't have to say anything about where this thing is running. So this works super fine when I run it locally, because Dapr will do it for me. Then I deploy exactly the same application, in this case to Azure Container Apps or Kubernetes, and it will work exactly the same way. I don't need to configure anything like where is that service located, on what port does it listen. The code is super simple. Same thing just to show you, for example, on the processor that actually saves the data. Again, it receives a post, and then basically the only thing I do is Dapr client save state into a state store. And then I configure to use Cosmos DB, for example, when I run in the cloud. I can use Redis when I run it locally. The code is exactly the same. So this means I can just run this. So I'll just hit this one to show you the application when I run it locally. And it's not really much to look at. This is the web page. It shows kind of the existing orders, and I can create new orders, which will then through the API send this PubSub event, and eventually the order processor will consume it, store it in Cosmos DB, and show it back here. And with the Dapr, if you install the Dapr extension, you get this extension in VS Code, and you can actually watch your application running here with your Dapr applications running and so on and so on. Okay, but this is kind of the Dapr part. Let's see what it looks like in Azure Container Apps, because I deployed everything. That's what I did half an hour ago through Azure Pipelines. So as I mentioned, you can deploy this Azure Container Apps using CLI, or you can use ARM or Bicep. So in this case, I'm using Bicep. And if you look inside this repo later, you can see this. You can also see how you would run this in the Kubernetes cluster. So I have code for that as well. So Bicep is the new way to write ARM templates. If you've done that before, how many have used Bicep here? A fair amount of you. That's good. It makes the things a lot simpler than it used to be. So let's just take a look at one of these things that deploys the container app using Bicep. And let's just see what's actually interesting here. I'm specifying the ingress here. In this case, this is the API. I want actually to have a public ingress to it. It listens to port 5000. I have some secrets for it to be able to actually pull the container image, specify the registry where it's that image located. The same information that I sent to the CLI before. So what's new here is this thing where I'm saying Dapr. So this is actually what I need to do just to say I want to use Dapr. So if I set this enable to true, this is what actually will spin up that sidecar. And I give it this name then, app ID order API. That's the name I'm using when I called from the web. It said order API. That's the kind of this is where I give it the name. And that's all I need to know later on. And let's take a look at this one as well. So the order processor. So this is the background thing that will consume messages from that queue. And it looks basically the same with one difference here. And this is the scaling part here. So let's take a look here. So then we have the scale option. And this is where I can specify how I want this to scale. So by default, you will set like min and max replicas. Currently, you can only have a maximum of 10 replicas because it's still in preview. But I can specify min, and I can actually specify 0 here for min replicas, which is quite interesting, actually. This means that I can actually scale this down to 0. And why do I want to do that? Anybody has some idea? Exactly, you pay nothing. And which is great for this kind of application. It processes messages on the queue, but if there's no messages, why do I need to kind of pay for it, right? So I can actually put a 0 there. And then I specify the rule for how to scale. In this case, I'm using and this is Keda then, actually. And I'm using the Azure Service Bus scaler. I say it to which topic inside my service bus to listen to. And I specify a queue length here of 1, which means that in this case, as soon as I have at least one message on that queue, I want you to scale up. This is not super realistic. You probably want to put that a little bit higher. But for demo purposes, I just have it set to 1. So basically, immediately when I get at least one message, it will start to scale out to process those messages. So I have a pipeline that deploys these things just using the deployment script. I'm basically just deploying the whole Bicep file. And let's go back to this one. So this is the other environment that I have, which is just called Container App. It's a great name. Right here, I have 3 apps, as you can see, same name. Order Web, Order API, and Order Processor. And let's just go to the Order Web and hope that it works. It didn't work half an hour ago, but I redeployed it. So I have the URL over here. And of course, in the real world, you would not use this URL. This is like the internal URLs you get. So you would map this to DNS or something. But you can see now this is the same, shows the same data. So it's the same application. There's no change to the code at all. I just deployed exactly the same thing to container apps using those Bicep files. So I want to show you, like, now this is running and it should work in the same way. So Azure stuff, 1, 2, 3. Let's just make sure it actually works. Yeah, so it works. So, okay, but let's say now that we actually get a lot of orders. Let's say it's Black Friday and everybody just keeps hammering orders. Then the order processor now only has like one instance. So it will consume one message at a time, which will not scale very well. So I have a little application that I will run to kind of send a lot of orders. And then I also have a little web app that shows the queue length of my service bus, which is currently 0. So this is just makes it a little bit more interesting to have something to watch when something scales. And also, I want to be able to actually look at how many instances do I have running of that order processor. They used to show that in the UI. They don't anymore, but we can actually run a command here to see how many instances that I have running. So let's run this one to see if I think that's the one. Yeah, so it's kind of hard to see, but I'm doing this. I'm watching, showing the latest revision, and then I'm picking out the number of replicas inside of it. And now it says it's one instance. So we can kind of peek on this one as the scaling start. So let's run this application, see if the internet works well enough to actually hammer it. So this application just basically sends a lot of orders to that API. And let's take a look at this one to see if. So now we can see that the number of orders starts to increase quite fast. And hopefully we should be able to see soon that the order processor starts to scale out and it will be able to kind of consume it faster. So there we go. You can see now that actually goes down very, very quickly. And then when it goes kind of low, so there's an algorithm to this, like it doesn't scale out immediately to 10 instances. It kind of looks at how much above your threshold is it, and it kind of figure out the best number amount. So now it kind of finds a good path where the number of items is quite steady. And if we go back here, and so it keeps sending messages here. So if we run the same command now, it's probably going to say something like 8 or 10 or yeah, so it's 9 now. So now it's up to 9 instances. And eventually, when the load decreases down to and I go below the threshold, Container Apps or Keda will actually scale my application down to the minimum number of replicas. So that's an example how you can use the auto scaling features of Container Apps without writing any code whatsoever. Just configure those scaling rules. And I think it really makes it super simple. And then, of course, in addition, you can base this on, as I mentioned, like the number of requests coming in. That's a simple thing for an API, for example, or on CPU or memory, if you have more like that kind of workload that actually consumes a lot of resources when it runs and you need to scale out. So I think that's pretty much it. Let's just talk a little bit about the pricing. So this is still in preview, so the pricing will change at least in terms of what you pay for it. But the type of pricing won't really change. And so what you're paying for now is the number of requests going in. So the first 2 million per month is for free, and then you pay 56 cents for the next million requests. And then you pay for like the resource consumption. And so you're paying for memory and for CPU, like virtual CPU. But you actually have two kinds of prices here. You have active usage price and you have idle usage price, which is lower. So active usage price, that's what you pay for when the thing is running, basically. But as I mentioned, you can have this. You specify that min replicas, the number of instances that you want to have. In some cases, you want to perhaps have a number of instances running in case you get a sudden load. So you want it to be even faster to process it. So if you scale down to min replicas, but they're not actually really running, that's what's called idle then. So and then you pay a much reduced price. So if you don't scale down to 0, you scale down to 5, for example, but they're not really being called, then they are considered to be idle, and you pay a lot less for those things. So again, the numbers will change over time, but this is how it will be priced then. So if you compare this to like a Kubernetes cluster, then even though you can scale a cluster up and down, you will always have nodes running. So if your application is is not really running in that cluster, you will still pay for all those virtual machines. Here you won't really pay anything. And that's really, like, I think, one of the big promises here, to make it much simpler to build the things, to host it, and basically only pay for what you actually use. So that was actually it. I have a URL here at the end where all of this code is available, so you can have a look on my GitHub account. And are there any questions? Mm-hmm. Yeah. So how does it work with the network? And I think I mentioned that, but if you don't specify anything, it will create a network for you. But when you create that environment, you can also specify an existing virtual network. So, for example, if you want to access kind of private resources on your virtual network, you can do that by basically creating an environment and pointing to an existing virtual network. That works well. Yes, a question? You mean for public access? Sorry, let's say for. Yeah. It's a good question. Actually, I think I read that it currently just uses port 443 and 80. Let me check that up. It might be that currently it only supports like web traffic from the outside. That's a good question. Let me check that up. Was there another one online? Yeah. Linker. I mean, it's Linkerd, I guess. Yeah. So what was the question? If you use it, if you can use it. Yeah. Yeah, you can use that. That's not really related to container apps, but yeah, a Linkerd is what's called a service mesh, which maybe the question is related to, like, because Dapr kind of solves the same thing that a service mesh does. So Linkerd is one of those service meshes that also do things like traffic splitting and secure communication between pods and so on. So we've used Linkerd in AKS and it works fine. You probably won't use it or you can't really use it in the container apps. So I'm not exactly sure what the question is, but today you can use it in AKS, but you can't really use it in container apps, and I don't think it actually makes sense because it kind of already provides the same functionality, in particular if you use Dapr. Was there another question? No? Yeah. Mm-hmm. A change of DNS name. If you change something in your service or that is breaking. Well, I mean, it's hard for it to handle breaking change that you made, of course, but you can use traffic splitting to not send traffic to it directly. So actually, what I didn't mention is it was quite recently added this thing called probes, which is also a Kubernetes thing. And this is really used. This is basically endpoints on your containers that container apps can call to make sure that you're up and running. So when you do deploy a new version, it typically can take some time before it's up and running. Maybe it needs to verify things. Maybe it needs to load some cache, load some metadata. So you typically don't want to send traffic to it immediately. You typically want to make sure it's up and running and it has kind of warmed up caches, and then you can say, okay, now I want you to switch traffic to it. So you can do this by implementing an endpoint called a ready probe. But still, if you have a breaking change, I wouldn't say that this service will really help you with that. You need to. Yeah, so I mean, you need to. If you do breaking change, you also need to make sure that your clients are also updated in the same time. So I mean, of course, you want to avoid breaking changes because it's required to deploy many things at the same time, and that's with microservices. We're trying to avoid that. We're trying to make sure that we can deploy each thing independently of each other. Yeah. Yeah. Okay. I don't think so currently. So in your pipe. Yeah, exactly. I would have suspected that's coming, but currently in your pipeline, as I do now, I push the image and then I trigger the deploy afterwards in the same pipeline. Or actually, the build part publish the image, and then you have the deploy part of the pipeline, which actually deploy the new version. But I know you can do that. You can't do that currently in Container Apps. And I typically always want to do this from a pipeline anyway. I like that better, but that's me. Yeah, but I think you typically also want some additional orchestration around deployment, and just immediately pushing it. Just because I push it to a registry doesn't necessarily mean that I want to deploy it immediately. But I would suspect that it's coming. What's your question here? No. All right, then I'll say thank you and have a nice rest of the day.